The penetration test, or pen test, is based on ASTM D5 and is a measure of the consistency of solid or semi-solid bituminous materials and is used to classify penetration-grade bitumens into standard ranges. The determination of the penetration value of bituminous binders. The following apparatus is needed to successfully complete the test. A penetrometer that allows frictionless vertical movement of the needle holder. A timing device capable of measuring a 5-second duration accurately. 3 tempered stainless steel penetration needles that meet ISO specifications. A needle holder and weight. A water bath capable of maintaining a sample temperature of 25 degrees Celsius. A specimen container and sample. You'll require a transfer dish having a minimum capacity of 350 millilitres if this experiment is done outside the bath. Preparation of the needle and needle holder. Clean the needle holder. Ensure that the holder, penetration needle and weight together total 100 grams. Examine the needle for defects. Clean the needle by immersing for 5 minutes in a 1% solution of oleic acid and toluene. Dry the needle. Assemble the penetrometer. Preparation of the sample. Heat the field sample in an oven or on a hot plate with great care, stirring when possible to prevent local overheating until it has become sufficiently fluid to pour. In no case should the temperature be raised to more than 90 degrees Celsius above the expected softening point of the bitumen. Fill 2 specimen containers to a depth of at least 10 millimeters greater than the expected penetration. Cover the specimen container with a lip beaker for 15 minutes to assist in the elimination of trapped air bubbles. Allow the specimen to cool at room temperature for an hour and a half. Place in the water bath at 25 degrees Celsius for the same period. Method. Remove the specimen from the water bath after an hour and a half and place it in a transfer dish that has also been in the water bath for 1.5 hours. Cover the specimen completely with water from the water bath. Place the transfer dish and the specimen on the penetrometer stand. Zero the penetrometer. Slowly lower the needle until it just makes contact with its image as reflected in the bitumen surface. Start the timer, which immediately releases the needle holder and allows the needle to penetrate the bitumen for exactly 5 seconds. Note the reading in tenths of a millimeter. Repeat the test to obtain 3 readings. The range of the 3 readings must not exceed the values given in the method. If acceptable, report the results in tenths of a millimeter and the test conditions. The softening point or ring and ball test, is a consistency test of bitumen, giving an indication as to the temperature at which the bitumen changes from solid to liquid. The determination of the softening point of bitumen by means of the ring and ball test. The following apparatus is needed to complete the test successfully. 2 steel balls, each having a diameter of 9,5 millimeters and weighing 3,5 grams. 2 shouldered rings, each having a diameter of 23 millimeters and a height of 6,3 millimeters. 2 ball guides made of brass. A ring holder and bottom plate 25 millimeters apart. A thermometer. A heat-resistant glass beaker. A spatula. A small metal plate. Glycerine and talcum powder mixture. A heating unit. Preparation of the sample. Heat the field sample in an oven or on a hot plate with great care to prevent local overheating until it's become sufficiently fluid to pour. In no case should the temperature be raised to more than 90 degrees Celsius above the expected softening point of the bitumen. Lightly coat the upper surface of the small metal plate with the glycerine talcum mixture to prevent the bitumen from sticking. Heat the 2 rings to approximately the same temperature as the sample and place them on the metal plate. Then, without delay, fill the rings with the sample so that there will be an excess above the top of each ring. Allow the filled rings to cool for 30 minutes at room temperature. Remove any excess bitumen by using a heated spatula so that the test specimens are level with the top of the ring. Start the test not less than 10 minutes and not more than 8 hours after leveling the specimens. Method. Assemble the apparatus by placing the filled rings in the ring holder and the ball centering guide on the rings. Also, insert the thermometer through the hole in the top plate. Fill the heat-resistant beaker with distilled water at a temperature of 3 to 7 degrees Celsius. Transfer the assembled apparatus to the beaker and ensure that the water level is 30 millimeters above the top of the rings. Maintain the temperature for 15 minutes at between 3 and 7 degrees Celsius. Place a steel ball on each of the test specimens. Heat the water so that the temperature rises at 4.5 to 5.5 degrees Celsius per minute. There are practical difficulties in obtaining the specified rate immediately after the heat is applied to the water. However, if after 3 minutes the rate of temperature rise does not fall within the specified limits, repeat the test. Read off the temperature shown by the thermometer to the nearest 0.5 degree Celsius at the instant that the bitumen surrounding the ball touches the base plate. If the difference between the readings exceeds 1 degree Celsius, repeat the test. Calculate the mean of the 2 recorded softening points rounded off to the nearest 0.5 degree Celsius. The xylene heptane, or spot test, is based on AASHTO T102 and is used to determine whether a bitumen has been damaged during processing due to overheating. The determination of the xylene heptane equivalent of bitumen, the spot test. The following apparatus is needed to complete the test successfully. 7 flasks. Wattman number 50 filter paper. A 10 milliliter pipette. A water bath at 32 degrees Celsius. A water bath at 100 degrees Celsius. A glass rod. 7 100 milliliter measuring cylinders. Heptane and xylene. And a gas burner or hot plate. Preparation of heptane-xylene solutions. Using your 7 100 milliliter measuring cylinders, make up solutions of 30% xylene to 70% heptane. (25% xylene to 75% heptane. 20% xylene to 80% heptane. 15% xylene to 85% heptane. 10% xylene to 90% heptane. 5% xylene to 95% heptane. And a 100% heptane solution. Warning: most organic solvents are toxic and highly flammable. Use only in a fume cupboard or in the open, away from naked flame. Preparation of samples. Put 2 grams of the sample into each flask. Gently heat the sample over a flame or a hot plate so that the sample lightly coats the bottom of the flask. Allow the samples to cool to room temperature. Method. With a 10 milliliter pipette, add the various xylene heptane solutions to the flasks. Rinse the pipette out with the solution before transferring it into the flask. Label each flask clearly. Insert the stoppers. Shake and rotate the flasks for 5 seconds. Place the flasks in a boiling water bath for 1 minute. Remove each flask, shake and rotate it to ensure mixing, and replace in the water bath. Repeat this procedure for 8 minutes. Remove the flasks and allow them to cool at room temperature for half an hour. Place the flasks in a water bath at 32 degrees Celsius to the nearest half a degree for 15 minutes. Remove the samples, swirl, and place them in an order of descending xylene content. Remove the stoppers. Insert the glass rod and place a drop of the sample on a piece of filter paper in front of the sample flask. Observe at which concentration the asphaltene spot begins to appear. Report. Report the result at the percentage xylene that the spot first appears. Also note the next highest concentration of xylene, where the spot did not appear. This example would be noted as 10% to 15% heptane-xylene equivalent. The rolling thin film oven test is based on ASTM D2872 and is an aging procedure which simulates the short-term hardening conditions which occur during the manufacture of hot mix asphalt. The performance of bitumen when subjected to the rolling thin film oven test. The following apparatus is needed to complete the test successfully. A specified glass flask, an ASTM 13C thermometer, and a rolling thin film oven fitted with a flow meter capable of accurately measuring the airflow at a rate of 4,000 milliliters per minute. Preparation of the oven. Position the air outlet so that it is horizontal and 6,35 millimeters from the opening of the glass container. Position the thermometer so that the bulb is within 25,4 millimeters of the horizontal plane passing the center of the revolving carriage. Ensure that the oven is level. Preheat the oven to 163 degrees Celsius to the nearest half a degree for 16 hours before beginning the test. Preparation of the sample. Heat the sample in an oven not exceeding 150 degrees Celsius. Manually stir to avoid creating air bubbles. Pour 35 grams to the nearest half a gram of the sample into each of the containers. Ensure that sufficient material is retained for comparative testing between samples that have been subjected to the rolling thin film test and those that haven't. Method. Arrange the containers in the carriage so that the carriage is balanced. Fill any unused spaces in the carriage with empty containers. Rotate the carriage at 15 revolutions per minute. Start the airflow at 4,000 milliliters per minute. Ensure that the oven returns to the test temperature of 163 degrees Celsius within 10 minutes. Thereafter, maintain this procedure for 75 minutes. Preparation for comparative testing. Remove the sample containers from the carriage in the oven. If the loss of mass is to be determined, the sample is cooled in a desiccator until it reaches room temperature. Weigh to the nearest 0,001 gram when it's cool to determine loss in mass. Pour the residue from the remaining containers into the relevant testing apparatus, for example, a ductility mold or a penetration cup. Do not scrape or reheat the sample being poured. Report. Report the changes in the physical properties before and after the rolling thin film oven test by determining retained penetration as a percentage of the original. Ductility. Loss in mass. Softening point. And change in viscosity. The Brookfield viscosity test is based on ASTM D4402 and is a consistency test which determines the resistance to flow of a bitumen subjected to specified shear conditions. The determination of the viscosity of bitumen using the Brookfield thermocell apparatus. The following apparatus is needed to complete the test successfully. A Brookfield thermocell high-temperature viscosity measurement system. Spindles. A sample chamber and an extraction tool. Preparation of the sample. Pour 8 to 10 milliliters of the heated sample into the chamber. Ensure that it's not overfilled. Method. Using the extraction tool, put the loaded chamber into the thermo container. Insert the selected spindle. Lower the viscometer, aligned with the center of the thermo container. Turn on the power to the thermocell and condition the sample for about